Hey, gonna do day 18 now. We just did day 17, but now we're gonna do day 18. Um, and let's get this show on the road. Duet. You discover a tablet containing some strange assembly code labeled simply Duet. Um, yep. Rather than bother the sound card with it, you decide to run the code yourself. Fortunately, you don't see any documentation, so you have to figure out what they mean on your own. It's like simply mention over a set of registers, each named with a single letter and can each hold a single integer. You suppose each register should start with a value of 0. There aren't that many instructions, so it shouldn't be hard to figure out what they do. Sound X plays a sound with frequency to the value of X. Set XY sets register value X to the value of Y. Add XY increases. Mul XY sets register X to the result of multiplying the value. Mod XY sets the remainder, recovers the frequency, but only when the value of X is not 0. If it is 0, the command does nothing. Juggas jumps with an offset the value of Y, but only the value of X is greater than 0, and offsets of 2. Jumps. Many of the instructions can take either a register or a number. The value of register is the integer it contains. The value of a number is that number. After each jump instruction, the program continues with the instruction to which the jump jumped. After any other instruction, the program continues with the next instruction. Continuing or jumping off either end of the program terminates it. For example, if I do this, set A1, add 2 to it, square it, and then set it to itself modulo 5, resulting in a value of 4. Then a sound with frequency 4 is played. After that, A is set to 0, causing the subsequent recover and jugs to be skipped. Recover because A is 0, jugs because A is not greater than 0. Finally, A is set to 1, causing the next jugs to activate, jumping back 2 instructions to another jump, which jumps again to the recov, which ultimately triggers the recover. At the time the recover operation is executed, the frequency lasts on 4. What is the value of the recovered frequency the first time a recovered instruction is executed with a non-zero value? Okay. So this seems fine, at least for the first part. As always, they're going to throw us a curve in the second part. I don't even know why this is called Duet, because there wasn't anything really duet about it. But so let's think for a minute about how we want to represent this. X is always going to be a register or a number. The value register could be, okay, this is, so, how do I want to represent this? I'm going to say an instruction is a string and a program is instruction equals string, and a program is a list of instructions. So I should probably use new types, but I'm not going to because I don't remember how they work in Python. So I'll just do this. Instruction is a string, a program is a list of instructions, and so I'm going to run a program, which is a program, and it is going to return an int, which is going to return the recovered frequency. And so, you know, let's say from collections import default dict. So we'll say registers is a dict from string to int equals default dict int. So it's going to be a default dict where if it's not there, we put a 0 there, because I think that's what it said, right? You suppose each register should start with a value of 0. Okay. And let's apply instruction, which is an instruction, and to registers, which is a dict of string to int, and it's going to return none because we're going to modify the registers in place. Actually, we need to keep track of the most recent sound played. So I'm actually going to do something slightly different, which is named tuple, and then what I'm going to say is class state, which is going to be named tuple. No, I'm going to do. All right, I'm just going to end up having a bunch of. This is going to be exactly like the last one, where when I initialize it, let's just say self.registers equal dict string comma int equals default dict int, and self dot last note equals, which is going to be an int, equals none, and none is technically not an int. Okay, and so I think that's fine. And so now I want to apply, instead of to just register, I'm going to apply to state. And so in run, I'll say state equals state. That's fine. And then return state dot last note. Okay, so I think that's good. And now we want to apply these instructions. And let me look at my input, because I think that will help me out a little bit. So the second one is always a letter, and the third one is always a number. But anyway, and let me just do the following: get self and name or value, which is going to be either a string or an int, and we're going to return an int. And what we'll say is if is instance name or value. If it's already an int, return name or value. Otherwise, return self.registers name or value. So I think that should be fine. Let's say pieces equals instruction.split, and what did I call this? Let's just say op equals pieces 0 and args equals pieces up to 1. So now, if op equals sound, what do I want to do? Value equals state.get args 0. So basically take the sound and let's say state.last note. Let me just do it this way, so I don't need value. So set last note to the value. And then elif op equals set. State dot registers. Actually, let me do this. Value comma equals args. I just think our code will be cleaner that way. Name or value equals args. Otherwise, if op equals set, register name or value equals args, and state dot registers register equals state dot get name or value. I guess I better call this one name or value as well. Return name or value. I better, because when I split this, I'm going to get things that look like ints. So otherwise, try return int name or value, except, and I think that's a type error. No, it's a value error. Except value error. So I think that's pretty good. I mean, it's messy, but it does what I want. So that's set. Elif op equals add. Register name or value equals args. State dot registers register plus equals state dot get name or value. And then I have mul, elif op equals mul, register name or value equals and you know what, actually I want to do a self dot current instruction equals 0 because we'll need that. Register name or value equals args. State.registers register times equals state.get name or value. Okay. And so I've got mul, I've got mod, elif op equals mod, register common name or value equals args, state.registers register. Actually, yeah, that's fine. State.registers register equals, I don't think there's an in-place mod. Maybe there is. Registers register mod state.get name or value. And then there's recover, elif op equals so what, return the recovered frequency. I don't want to handle recover in here, and I don't really want to handle jump in here either. So let me do the following. Else raise value error unknown op Okay, so what I'm going to do is I'm not going to do an instruction. Instead, I'm going to do an op, which is a string, and args, which is a list of union string ints. Okay, so that's fine. So now I want to run a program. Okay. And so what I want to do is I'm going to change. Actually, I'm going to change instruction. Class instruction named tuple. Op is a string, and args is a list of union string, int. I hate union types, but I've sort of wedded myself to using them here. And so now let's go back and say instruction op equals instruction.op, args equals instruction.args. So, and a program is a list of instructions. Okay. So, let's say pause equals 0, and while true, and so what do I want to do? I want to say instruction equals instruction pause. Okay. And if instruction.op equals, and let's take care of these last two that I didn't take care of, equals recovers the frequency of the last sound played, but only if the value of x is not 0. Okay. If instruction.op equals recover, value equals state.get instruction.args 0. And now if value, and what did it say? It says only when the value of x is not 0. If value is not equal to 0, and I want to recover. And now, what is the value of the recovered frequency the first time? So I just want to return this. So return state dot last note. So that's going to be good. And then otherwise, we don't do anything. Otherwise, if instruction.op equals, I think it was jump, JGZ it was called. JGZ. Jumping back 2 instructions. So let's look at JGZ. JGZ jumps with an offset the value of y, but only if the value of x is greater than 0. An offset of 2 skips the next instruction, and an offset of -1 jumps the previous instruction, etc. So if value equals state.get instruction.args 0, if value is greater than 0, that's not what they said, only if value is greater than 0, pause. Actually, no, there's 2. So let's say x comma y equals instruction.args. If state.get x is bigger than 0, pause plus equals state dot get y. Otherwise, don't do anything. And then finally, in this last case, this is, do something with the state. And let's say apply instruction to the state. And then I think we want to go to the next to the instruction. These are the next instruction. Continuing off either end of the program terminates it. So let's say pause plus equals 1. And then if pause is less than 0 or pause is bigger than len instructions, raise runtime error terminated with, I'll just say terminated. So I think this is pretty good. And finally, let me just write a parse raw, which is a string, into a program. And what do I want to do? I want to say lines equals raw dot split on new lines, right? And fields equals line dot split for line in lines, and then return what's called instruction takes an op and an args. Turn so actually, you know what? What's going on here? These are always going to be strings, so I can get rid of a little bit of this. So this is just going to be a name or value is going to be a string for sure, and it's never going to be an instance of an int. And I'll just try. So that makes more sense. Instruction, field 0, field 1 for field in fields. So I think that's right. And then let's just say test input is going to be this. Test instructions equals parse test input. So let's try this. Run day 18 duet.py test instructions. So set A1, add A2, multiply AA, mod A5, sound A, set A0, recover A, jugs A -1, set A1, jugs A -2. Okay, so that actually looks pretty good. So what happens if and you know what? Let's just say print pause instruction, and then also print state dot dict. So, and what did I call this? Run test instructions, local variable instruction, because that should be instruction equals program pause, because program is just a list of instructions. And so this should be len of program. So let's try that one more time. And that's not good. So, and I need to do pos plus equals 1 here too, right? So if we recover something, we still go on to the next. And also here, I probably need to do pos plus equals 1 so that we don't keep doing that. And then otherwise pos equals 1. Okay, so let's try that again. And so now let's make sure that this is working correctly. The first 4 instructions, let me put this down here. Okay, good. So the first 4 instructions, set A to 1, add 2 to it, square it, and then set it to itself modulo 5, creating a value of 4. After that, A is set to 0. After which there's a recover that does nothing, and a jug that does nothing. And then we set A to 1, and then we do a jugs minus 2, and then that jugs minus 1, and then we recover A, which ultimately triggers the frequency of the last note played is 4. So that seems to have done the right thing. So let me comment these out. And now let me download the puzzle inputs. Save link as day 18 input.text. And so if name equals main. Actually, you know what? I'm gonna and I'd like to print the state before I do that too, because I think that makes more sense. So if name equals main with open day 18 input.text as f, raw equals f.read dot strip program equals parse raw, and let's just say print run program. Oh, that was not the right thing. Okay, 9423. So let's do 2 things. One, let's look at this puzzle input. Okay, so goes through a lot of steps. Let me do this. Get a big blank spot that I can find when I scroll back. So this is a lot of instructions. A lot of instructions. Seriously? Okay, so watch this. Shell, edit, clear scroll back buffer. So now I can't scroll back. So now if I scroll back as far as I can, it will get me to where I want to be. Good. So I set I to 31. I set A to 1. I multiply P by 17, but P is 0, so that's fine. I try and jugs P, but P is 0, so that doesn't do anything. Then I multiply A by 2, so A goes to 2. I add I to minus 1, so that's fine. I jugs I minus 2. And and that works. So now I'm back to instruction 4, and I multiply a by 2. So a is 4. What? Okay, so this all seems pretty reasonable. So, and it printed 9423. So let's try that. That is the right answer. Good. Let's look at part 2. So congratulate you. Notice the documentation has been in the back tablet the entire time. We got most of the instructions correct. There are a few key differences. This assembly code isn't about sound at all. It's meant to be run twice at the same time. Each running copy has its own set of registers and follows code independently. In fact, the programs don't even necessarily run at the same speed. To coordinate, they use the send and receive instructions. Send X sends the value of X to the other program. These values wait in a queue until that program is ready to receive them. Each program has its own message queue, so a program can never receive a message it's sent. RCVX receives the next value and stores in register X. So, if no values are in queue, the program waits for a value to be sent to it. Programs do not continue to the next instruction until they have received a value. Values are received in the order they are sent. Okay. Both programs begin by sending 3 values to the other. Program 0 sends 1, 2, 0. Program 1 sends 1, 2, 1. Each program receives a value, both 1, and stores it in A. Receives another value, both 2, stores it in B, and then each receives the program ID of the other program. Stores it in C. Each program now sees a different value in its own copy of register C. Finally, both programs try to receive a 4th time, but no data is waiting for either of them, and they reach a deadlock. When this happens, both programs terminate. It should be noted that it would be equally valid for programs running at different speeds. For example, program 0 might have sent all 3 values and then stopped before program 1. Once both of your programs have terminated, how many times did program 1 send a value? Okay, so this is, not sure we're going to be able to use that much of our previous let's think about this. This will be a little bit complicated. Each running copy of the program has its own set of registers and follows the code independently. Okay, so class, I'll call it copy, even though it's a copy of a program. So init self, and let's say program is a program, which is just a list of instructions, and that's fine. And it also gets a program ID. Program ID, which is an int. So self.registers, which is a dict from string to int, equals, actually, no. Self.state equals state. You know what? Because the send and receive are totally different, we're going to have to just rewrite some of this. So what I am actually going to do is I'm just going to make a second program. So file, save as day 18 duet v2.py, and that's going to be fine. So we can leave instructions as the same, although actually these are just a list of strings, which is fine. And state is going to be, and now we don't need to store the last note, but we have a self dot each program has a message queue. So queue equals dec, And so let's do from collections import. Dec is just the double-ended queue. And that's fine. Def enqueue self state, or let's say value, which is an int. It's none, and we'll just say self.queue.append value, and def dequeue self goes to int, and we would say if self dot queue. So if the queue is not empty, return self dot queue dot pop left, and then otherwise I'll just say return none. So that if you try and dequeue and you get none, that means the queue is empty, and then we have this whole get thing. And then the state, let's do a program ID, which is an int, which we need. And we said self.registers p equals program ID. So that's fine. And now when we have these and let's just say self.otherQ equals none. So we'll need to assign the other program's queue to this thing. And now what we're going to do is we're going to change this to a bool. And it's going to return true if the apply succeeded, false otherwise. So like the idea is that sometimes we might, so if up equals send, name or value, and so now so now let me look at this again, and let me this. Send x sends the value of x to the other program. Name or value equals args, and then what I want to do is I want to say state dot. And actually, you know what? Rather than other q, I'll say self dot other state. State equals none. So I'm going to have each of them know the other states. So when I want to send the value, state dot other state dot enqueue state dot get name or value, and then return true. And then otherwise, if it's set, I'm going to return true. And if I do add, it's going to return true. Actually, you know what? It's going to return true almost every time. So I'm just going to put that all the way at the end. Return true. And so now these other two instructions, JGZ is still fine, and we still want to behave it the same way. But the receive is totally different. And I'm just going to stick it first. If op equals receive, get the value out of the queue. Value, and how does receive work? Let me look at this again. Receive x receives the next value and stores it in register x. register comma equals args. Value equals state dot dequeue. If value is none, then return false. Otherwise, so we're going to use this to sort of coordinate, and because sometimes you'll want a value and there's nothing to do, and so I think this will work okay. And otherwise, state dot register equals value, and return true. Okay, so I think this is good. And now program's list of instructions, and state and now I probably want to move the position inside the state as well, because each program should self.pause equals 0. So I'm going to store the position of each program inside its state as well. And what am I trying to return here? How many times did program 1 send a value? Okay. So I'm just going to do something terrible and say self dot program 1 sent a value equals 0. Actually, let me do self dot, this will be a little bit cleaner, self dot sent a value equals 0. And so if send state other state in queue state dot sent value plus equals 1, so that's fine. Okay, so now here's what I want to do. I want to say state 0 equals state program ID equals 0, state 1 equals state program ID equals 1, and and actually, now that I've done that, I can actually move this inside here as well, which is good. So elif instruction op equals jgz, do xy equals instructions args, if state dot x state dot pause to state dot y. Else state dot pause plus equals 1. And you know what? If I do this, I'm just going to return true, and that way I can do this right there, which makes things really messy, but that's fine. So while true, and actually apply program. No, that's Yeah, I think, so let me change this to, let me just call this step program, which is a program, and state is a state, which is a bool, and let's say instruction equals program state dot pause. It's actually, I think, a cleaner design in some ways than the other one. So while true, step 0 equals step program state 0. Step 1 equals step program state 1. If not step 0 and not step 1, deadlock. And so when that happens, both programs terminate. Print deadlock and return. Okay. And return how many times program 1 sent a value. So that's state 1 dot sent a value. So now for this example, so let's try, we have a different test input, which is very simple. Send 1, send 2, send P, receive 1, send test instructions, and let's comment this out. And let's say print run test duet v2 return instruction field 0 field 1. So what did I do wrong? Step program mypi day 18 duet v2.py. Something's gone very right. So dict is not defined. 17, you type annotation for variable. Q of ints. I think there's probably a Q type. Module typing has no attribute Q. So let's look that up. Python typing Q. No Q, huh? Okay, so I guess I can't type into Q. That's fine. So instead, I will do oh, well, watch this. This is cheating, but it works. Argument 1 to run has print run test instructions. So that was actually my problem all along. So I Python. Yes, that is true. So what I need to do is I need to do state 0 dot other state equals state 1 and state 1 dot other state equals state 0, and I forgot to do that. So and it appears to not be working. So let's go see what it's doing wrong. So let's print state dot dict print instruction. So let's try that again. Receive, so state.dict registers, queue is empty. So again, let me clear the scroll back buffer and try this again and just break it immediately. And it still ran very far. So send one. So here we have this queue. And it doesn't have a program ID in its state. That's a real nuisance. Well, it has the P, I guess. So this is program 1. It has a queue. Program 0 has a queue. Program 1 has a queue. 1, 2, 1, 2, 1, 1, 2, 0. And now he dequeues, he dequeues, he dequeues, he dequeues, receive into A, receive into A, and then it's deadlocking, but it's not stopping. So why is that? Print dequeued value. Okay, so edit clear scroll back buffer, and again, let's go and see what it's doing. Dequeued 1, dequeued 1, dequeued 2, dequeued 2, dequeued 1, dequeued 0, dequeued none, dequeued none. So he dequeued none, he dequeued none. So that's fine. And so it should return false. If not step 0, so print step 0, step 0, print step 1, step 1. So again, let's clear the scrollback buffer and let's run this guy and now scroll back. And oh, duh, because this should be inside the while block, not outside of it. So deadlock and then 3. So that was stupid. Once both your programs are terminated, how many times the program wants to send a value? Okay, so now we should be able to do the same and print run, and it's actually the same code. So let's just, okay, but that doesn't seem right. So let's look at that program. It definitely let me do something slightly different, which is if op equals send, print that and print instruction. So let's again clear the scrollback buffer and run it again. Set to value 0, set to value 1. Let me I feel like I'd be happier if I did self.programID equals program ID, and then I can see why is it always program ID 0 that's sending something. So in step, I'm going to say print a program state.programID, and then print. So if I run this again, and now let me clear the scrollback buffer and run it again and see what it's doing. So I start with program 0, and his instruction is send 1. So I go to program 1, he's got 1 in his queue, and he did I screw something up, and was I supposed to start oops, that's let me stop this and again clear the scrollback buffer and run it again. Now let's go back and make sense of this. So program 0, he sets I to 31. Program 1 also sets I to 31. So now he sets A to 1. He sets A to 1. That's fine. Program 0 sets P to 17. Program 1 sets P to 17. So at that point, they both have the exact same. Let me make sure I understand this correctly. Register P should be sent with this value. Right, we multiplied P by 17. So 1 P goes to 1 is 0, 1 is 0. And then I jugs P to P, so that's going to go nowhere. And then I jug somewhere, so that's going to go somewhere. And then program 0 multiplies program 1, jugs A3, and so that should go from pos 20 to pos 23. Let me just keep looking at program 1. He wants to set F to 0. Okay. And then program 1 wants to set I to 126. And then program 1 wants to receive into A. So now program 1 got a but that seems wrong. Am I not doing receive properly? No, that does seem proper. So when I got that, I want to receive into A, but I have nothing in my queue, is that right? So program 0, program 1 is still receiving into A. Program 0, program 1 is still receiving into A. Program 0, program 1 is still receiving into A. Program 0. And so let's program 1 is just hanging out until there's a send coming from the other side. So no sent to value, no sent to value, no sent to value. It's still just waiting to receive, still just waiting to receive, still just waiting to receive. And meanwhile, the first program is doing all sorts of stuff. Okay, here we have some sent to values now. Sent to value 0. No, that's still come back. Sent to value 22. Sent to value 21. Sent to value 17. Well, hold on. Here we have sent to value 16, but this guy's still waiting to receive. And he's got nothing in his queue. So somehow this, he wants to send B. And then when it gets to be this guy, his queue actually is 1744. But he's receiving A. And then is he not moving on? Is that the problem? I knew handling the pause in this way was going to cause me a real amount of grief. So let's make sure that if I received, I don't want to advance the pause. If I didn't get anything. If I did get something, I do want to advance the pause before I return. And jugs, I want to advance the pause like that. Okay. So that's a lot. Let me go comment out that print because it's printing a lot. 7620. All right, that seems more reasonable than 0. I don't know if it's right, but it seems more reasonable. So let's try it. That is the right answer. Good. Okay, so I got rank 392 on this star's leaderboard. Okay, but not... Anyway, cool. That one, it was intricate, I guess. But we got it to work, and we spent... Wow, we spent an hour on that. Okay. It's a long problem, I guess. Okay, find me on Twitter. I can't believe I spent an hour on that. It didn't seem like an hour, but it was an hour. All right, cool. Thanks for watching. See you next time.